Capacity and facilities planning is a cornerstone of effective operations management, shaping an organization's ability to meet customer demand while balancing costs, responsiveness, and competitiveness. Whether you're manufacturing products or delivering services, the decisions you make about capacity directly impact your organization's performance and long-term strategy. Today, we'll delve into 5 essential concepts that form the foundation of capacity planning: understanding capacity itself, analyzing bottlenecks through the theory of constraints, TOC, leveraging break-even analysis for decision-making, mitigating risks with incremental changes, and applying expected monetary value, EMV, to navigate uncertainty in capacity decisions. Let's begin with 3.1. Capacity, the fundamental concept that defines the maximum output a process or facility can achieve within a specified time frame. Capacity can be expressed in various units depending on the industry, such as units per hour in manufacturing, customers served per day in retail, or tons processed per month in logistics. It's important to distinguish between design capacity, which represents the theoretical maximum output under ideal conditions, and effective capacity, which accounts for real-world factors like equipment downtime, maintenance schedules, employee breaks, and other operational realities. Effective capacity is often lower than design capacity, reflecting the practical limits of a system. Running operations consistently above effective capacity can lead to serious consequences, including decreased product quality, extended delays, and employee burnout. To avoid these pitfalls, organizations must strive to align capacity with demand, ensuring there's neither too little capacity to create bottlenecks nor excess capacity that wastes resources. This requires a careful balance, as overinvesting in capacity can lead to unnecessary overhead costs, while underinvesting can result in missed opportunities and dissatisfied customers. This brings us naturally to 3.2, bottleneck analysis and the theory of constraints, TTOC, a powerful approach to identifying and addressing the weakest link in a process. A bottleneck is the specific point in a system where capacity is limited, restricting the overall output of the operation. Think of it as the narrowest section of a pipe that determines how much water can flow through. For example, in a busy cafe, the coffee machine might only be able to prepare 2 drinks per minute, while the cashier and kitchen staff can handle 4 orders in the same time frame. In this scenario, the coffee machine becomes the bottleneck, effectively capping the cafe's ability to serve customers efficiently. The theory of constraints, introduced by Eliyahu Goldratt, provides a structured methodology to address bottlenecks. The process involves 5 key steps. 1. Identify the bottleneck, pinpointing the constraint that limits overall capacity. 2. Exploit the bottleneck by maximizing its efficiency and utilization. 3. Subordinate other processes to support the bottleneck, ensuring they don't outpace or overwhelm it. 4. Elevate the bottleneck's capacity by investing in improvements, such as adding equipment or reallocating resources. And 5. Once the bottleneck is resolved, repeat the cycle to identify and manage the next constraint. This iterative approach ensures continuous improvement and helps organizations achieve a more balanced, efficient operation. Next, we turn to 3.3, break-even analysis, a critical tool for making informed capacity and investment decisions. Break-even analysis examines the relationship between costs, production volume, and profitability, helping managers determine the point at which total revenue equals total costs, known as the break-even point, BEP. At this level of output, the business neither incurs a loss nor generates a profit. The formula for calculating BEP is straightforward. Break-even quantity, fixed costs. Price, variable cost per unit. For instance, imagine you're considering opening a second branch of your restaurant. Break-even analysis can help you calculate how many customers you need to serve daily to cover expenses like rent, salaries, and utilities. Beyond the break-even point, each additional unit sold contributes directly to profit. This tool is invaluable for evaluating decisions such as whether to expand capacity, outsource production, or invest in new technologies. It also enables managers to conduct what-if scenarios, exploring the financial implications of changes in pricing, fixed costs, or variable costs. Capacity planning often involves navigating uncertainty, which leads us to 3.4, reducing risk with incremental changes. Predicting future demand, technological advancements, or competitive shifts can be challenging, and large, irreversible investments in capacity can expose organizations to significant risks. An effective strategy to mitigate these risks is adopting incremental capacity increases rather than committing to large-scale expansions. This approach allows businesses to add capacity in smaller, manageable steps that align with actual market growth. For example, instead of constructing a massive new factory, a company might expand an existing facility, lease temporary space, or partner with third-party manufacturers. Incremental changes offer flexibility, enabling organizations to adapt to evolving circumstances without overcommitting resources prematurely. They are particularly valuable in industries characterized by volatile markets or rapid technological disruption, where agility and responsiveness are critical to maintaining competitiveness. Finally, we arrive at 3.5, applying expected monetary value, EMV, to capacity decisions, a quantitative tool designed to address uncertainty in decision-making. EMV combines the probabilities of different outcomes with their associated financial impacts, providing a single figure that represents the expected payoff of a decision. The formula is EMV equals S, probability of outcome, X monetary value of outcome. Consider a scenario where you're deciding whether to build a small, medium, or large factory. Each option has distinct costs and potential payoffs depending on whether market demand turns out to be low, medium, or high. By estimating the probabilities of each demand level and multiplying them by the corresponding profits or losses, you can calculate the EMV for each alternative. The option with the highest EMV represents the most rational choice under uncertainty. This method enables managers to make data-driven, risk-aware decisions, particularly in large-scale, long-term capacity planning. In conclusion, capacity planning is not merely a technical exercise, but a strategic endeavor that requires balancing quantitative analysis with foresight and adaptability. By understanding capacity limits, addressing bottlenecks, leveraging break-even models, managing risks through staged investments, and applying EMV to navigate uncertainty, organizations can position themselves to deliver on time, control costs, and adapt to growth. As future managers, mastering these tools will empower you to ask critical questions, such as, are we operating within our capacity limits? What constraints are holding us back? Should we expand, outsource, or delay investment? By thoughtfully addressing these questions, you'll be better equipped to drive operational excellence, support organizational growth, and contribute to long-term success. In our next session, we'll dive into facility location and layout design, examining how strategic decisions about where to place facilities and how to design layouts can optimize efficiency and enhance customer experience. Thank you, And I encourage you to reflect on today's concepts by analyzing a business you know. What is its capacity? Where are its bottlenecks? How would it respond if demand suddenly doubled?